Hello, this is Mr. Stansbury. I'm going to take you through the problem solving notes. And this is problem solving with Pythagorean Theorem. So at the end of this, you should be able to say, I can use Pythagorean's Theorem to solve various real world type problems. Okay, let's take a look at the first example here. Example 8, Randy has a 17-foot long ladder that just reaches to the bottom of a window on his house. The bottom of the ladder is 4 feet from the house. How high is the bottom of the window above the ground? So here's the ladder, 17 feet, reaches just to the bottom of the window, and it says right here, the bottom of the ladder is 4 feet from the house. So here's the house right here. They're trying to figure out how high is this right here. So what's that length? Okay, we're gonna assume here that the house is built with a nice plumb walls, which means nice and straight up and down. And here's the level ground that they hopefully built it on. Okay, so what we're trying to figure out is this length right here. Okay, so that's how high it is from the ground to the bottom of the window. So, well, now we just have a nice Pythagorean theorem to figure out what this missing side is here. So this is our hypotenuse, right? So we would take our hypotenuse, which is 17, and then our two legs are x and 4, right? So we get x squared plus 16 equals 17 squared, which is 289. So that's 289. Subtract 16 from both sides, and we get x squared is 273, right? So we just need to square root both of those to figure out both sides to figure out what x is. So take the square root of 273, and we get 16.522, first, second, third significant figure. So that's going to be 16.5 to 3 significant figures, and this is feet. Okay, so from the ground to the bottom of the window is 16.5 feet right here. Okay, all right, let's take a look at another example, and away we go. So Sarah is hanging a disco ball in her room. If she hangs the disco ball in the center of the ceiling, how far is it from where the disco ball is hanging to the corner of the room? So what she's saying is, how far is it from where the disco ball is hanging to the corner of the room? So since this is a perfectly, rectangular prism here, it doesn't matter which corner you draw it to, which corner we measure to, they're all going to be the same. Okay, so what we're trying to figure out is, let's see, that's going to be this length here, right? Which is kind of hard to envision because it's a three-dimensional shape here. So we're trying to figure out what that is. Okay, so in order to figure out what that is, let's draw ourselves a nice little right triangle here. So if we draw that there, now we've got this nice right triangle here. We're trying to find that length there. Okay, we know for sure that this has to be a right angle for our right triangle here. So let's just redraw this really quick underneath here. So this is this distance here. This is our height. So there's our right angle. And this length there, that's what we're looking for. There's our x. Okay, so we don't know what that is, but we do know that this here is 8 feet. Okay, so we just have to figure out, if we can figure out what this is, we can figure out what that is. Okay, so in order to figure out what that is, we're going to have to do some Pythagorean theorem just to figure out what that length right there is, right? So let's use a different color to hopefully make this a little easier to see. So what we're going to try to do now is we're going to try to figure out what that length right there is. So if we do that, and then, I don't know, maybe let's draw, it doesn't really matter. We can either draw a line to this side here, or I'm going to draw a line to this side over here, and then another line right there. I've now made a nice right triangle. So there's our, it doesn't look like it, but when you look at, if you look at this from the top, I didn't really draw that to the best spot there. That should be a little bit more straight. Let's fix that. Okay, so there's the middle of the room. So there's our right triangle. So if we were to look at this from the top down view, so if we're looking here, looking down on that, then here's our right triangle or right angle. So if we're looking at that, let's draw this. Okay, so we've got this here. So right up here is where the disco ball is going to be. There's our right angle. That's this piece right here, and then this over here is this point right there. That's that corner. Okay, so let's see. This, since we know this is exactly in the center of the room, we know that this length right here is going to be half of this length right here, which is 13. So this right here is going to be 13 over 2, which is 6.5. And that is, what are these? Feet, 6.5 feet. Okay. We also, since again this is hanging right in the center of the room, this right here, this piece right here, which is this right here, is going to be half of this length right here, which is 12. So we take 12 divided by 2, and that gives us that this is 6. Okay. So to figure out what this length right here is, which is going to be the same as, let's call this y now. I know it's getting a little confusing to look at there, but there's our y. So to figure out what this y right here is, which is the same as this, we would obviously use Pythagorean Theorem. So y is our hypotenuse, so we're going to do 6 squared plus 6.5 squared is going to equal y squared. Right? So 6 squared plus 6.5 squared gives us 78.25. So to get rid of the square, we got to square root both sides. And we get that y is going to be the square root of this. Square root our answer. Oops. That's not what I wanted. Square root our answer. Ooh, I messed that up somehow. Let's try this again here. Okay, got our 78.25 back, so we square root our answer. I did entry, that's why I messed that up. So square root our answer, and we get 8.845. First, second, third significant figure. 5 turns the 4 into a 5, so we got 8.85. So this is 8.85. So now we have these two sides, and we can then figure out what this side is here, this x. Right? So let's go back to our blue here. So x is going to be our hypotenuse. So we got x squared. And then we've got 8 squared plus our 8.85 that we just found. Right? So we've got our 8.85, but again, that was squared. So if we take that number and we square it, guess what we get back? 78.25. So we'll take 78.25. Oops, sorry. That's weird. So 8.85 squared is 78.25, and then we got to add 8 squared, right? So let's just do this. We'll square that. There's our 78.25 plus our 8 squared, which we know is 64, but we get 142.25. 142.25, and then we square root. Oops, I can't see that. Square root both sides, and we get that x is going to be square root our answer, and we get 11.926. So first, second, third significant figure. 2 tells the 9 to stay the same, so we get 11.9 feet is what this length should be from the center of the room to any one of those bottom corners. Okay, that's a little trickier. You gotta there's a couple things you got to do in this. You got to be able to redraw things like three-dimensional triangles back into 2 dimensions, because that's kind of a weird, it's not a 3-dimensional triangle, but in 3-dimensional space here we got to redraw that so that it looks a little easier to figure out. And then we had to figure out this one first just to figure out that length so that we could figure out this length here. So that takes a little bit of work to figure out, but just take one little step at a time and you should be good. Anyway, that's all there is for this here. If you have any further questions on this, please feel free to ask in class. Thanks.